I'm Anil Kumar, and now we will solve a trigonometric quadratic equation. The equation given to us is zero point 0.9 tan square x plus 0.6 tan x minus zero point 0.1 is equal to 0. So in this particular case, what we can do is we will actually use the formula, quadratic formula, which is if the equation is ax square plus bx plus c equals to 0, then the solution is x equals to minus b plus minus square root of b square minus 4ac over 2a. So we can directly use this formula in this particular case. Here the variable, however, is not x for us, but it is tan x. Okay, so tan x is our x, correct? So we have a equation which is quadratic in nature, right? So we'll use the formula and then find the solution. So let's begin by recognizing that tan square x is our variable. So in that case, what is the value of a, b and c? Now a is coefficient of tan square x. So we can say, let me write it in a different ink. So we have a as 0.9 and we have b as 0.6 and c is minus 0.1. So we'll apply the formula directly and find the value of tan x. So we can now write tan x as equals to minus of b means minus 0.6 plus minus square root of b square means 0.6 whole square minus 4 times a is 0.9 and c is minus 0.1 square root divided by 2 times a, which is 0.9. So that becomes our formula for finding tan of x. Let's find this value using the calculator. So first let's solve the radical part of it, which is square root, and within square root we have 0.6 square and then we have minus 4 times 0.9 times minus 0.1, right? So that gives us a value which is equals to 3 square root 2 over 5. Anyway, let's convert it to decimals, or well, we are using calculators, so there is no problem. Let's use decimals. So we have minus 0.6 plus minus 0.8485. Let's use 4 decimal places, divided by 2 times 0.9 is 1.8. Correct? So that gives us two possible solutions. Always you could get two possible solutions. In one, we will add. So one is with, we have to take away minus 0.6 from this value, or you add this value with a negative sign. So this is what we are going to do now, and then divide by 1.8. So that is our value which we are going to use to approximately get the answer. So the first one, I'm going to just take away 0.6 from this value, and then we get one expression, and we'll divide this by 1.8. So we get minus, okay, so let's convert to decimals. We get one value is 0.1380. So that is the value for tan of x. So once you get the value of tan of x, you can find what x is, correct? So let me continue with this and find the value of tan of x for this particular value, since it is there in my calculator. So that could be faster. So tan inverse, so we are saying that tan of x equals to 0.1380. That means x is equals to tan inverse of this value, 0.1380. Remember also that tan of x is positive in 2 quadrants, or you can say tan has a time period of pi. We have to give solution from 0 to 2 pi, correct? So we are expecting two solutions, one in the first quadrant, the second one in the fourth quadrant, correct? So when we do tan inverse of this value, so shift tan inverse of the answer within brackets is equal to what? You get radian answer, which in our case is equal to 0.13, and let's 137. Fine, no problems. So this is one answer. So we'll say now the solution is x is equal to this, or it could be the other answer will be, so we'll call this as the acute angle answer. The other one will be pi plus this. So let's add pi to this. So shift pi plus the answer, right? So we get 3.27. So we have two answers. This is the first one, and the second one is 0.137 plus pi, which is 3.278. So these are two solutions for one of our values, in which we utilized minus 0.6 plus this. Now what we are going to do is, we are going to use the same value with the negative sign, correct? And then find the other two solutions, right? So let's do it again. We have 0.8485. This is with the negative sign, so I'll write negative later, plus 0.6. Both are negative, so I'm writing this in decimal as minus 1.4485. Minus 1.448. Okay, I have to divide by 1.8 also. Divide by 1.8 equals to, in decimals, 0.800 sorry. So this was to be divided by 1.8, so that gives us 0.8047. Okay, so we get this value. Now once you get that value, let me do the second half here. So now we have to find solution for tan equals to negative of this value. So let me do, okay, so we have now tan x could be equals to negative of 0.8047. Now in such cases, you should find the related acute angle, correct? Let me explain you this part. So we actually want to find two answers for which tan is negative. That means we are expecting solutions in quadrant 2 and 4, right? You remember the cast rule? The cast rule is tan is positive in first and third quadrant, but negative in second and fourth. Now how to find this answer? So you find first the related acute angle alpha. So you know the acute angle from where you can find the answer. So we'll write here tan of alpha equals to 0.8047. So alpha is tan inverse. So from the alpha is equals to, we already have this value for us. Now we'll do shift tan inverse of the answer equals to. So we get a value of alpha as 0.6776. You get the idea. You'll also appreciate why I leave the value in the calculator itself and do not retype it, because that could give me errors, right? So I'm trying to avoid those errors. Okay. Now once I get my alpha, then what are the values for x? Now in that case, x, you know, will be equals to pi minus alpha, or it could be pi 2 pi. So that is, this one will be 2 pi minus alpha, right? So we'll take away this value from pi to get the solutions. So pi, you can use 3.14 as pi, or the accurate value of pi minus the answer. So the answer is equals to 2.463, I'll round it to 4. And in this case, 2 times pi minus alpha is 0.6776 equals to, the other value could be 5.6055. Okay, so we get 4 different solutions for this particular question. Now let's combine all these solutions and write down our answer. So answer is x is equals to 0.137, 3.278. This is when we use the positive value, or we get 2.464 or 5.6055, since we have to give all possible solution in the required domain. So I hope you understand the strategy here.